Hello, everyone. Today we are going to work on the applications. So word problems using sine and cosine. Reminder, you want to make sure your calculator is in the degree mode. So to review how to do that on your calculator, I'm going to quit out of where I am. I'm going to hit the mode button, which is right next to the second button, the blue button. So it's mode. And then you want to arrow down, and you can see mine says radians right now. So I want to arrow over to degrees and hit enter. And then I can do second quit to get out of that. And that means my calculator is now in degrees. You want to make sure your calculator is in degrees when you're doing trig. Your calculator, once you set it that way, unless you reset it, should stay in degrees, but it's always a good idea to check it. So what I would like you to do with these problems is I would actually like you to pause the video right now, try number one, and then come back and check your answer. So number one, it says the bus drops you off at the corner of H Street and First Street at approximately 300 feet from school. You plan to walk to your friend's house, Janet's, after school to work on a project. Approximately how many feet will you have to walk from the school to Janet's house? Round your answer to the nearest foot. So if we look at this diagram a little closer, we're walking here from the school to Janet's house along that road. This angle is given, that's 41 degrees. So in terms of that angle, well, what we're looking for is the hypotenuse, because the hypotenuse is always relative to the right angle. And across from that 41 is our 300, so that's opposite. So the first thing we need to do is think about what ratio uses opposite and hypotenuse. So that ratio is sine. So it's sine of 41 is equal to our opposite over our hypotenuse, and it's always the sine of our angle. So sine of 41 equals 300 over x. Sine of 41 is just a number, but I'm not going to find that yet. I put it over 1, I cross multiply. I have x times the sine of 41 equals 300. I divide both sides by the sine of 41. And then I'm going to do that on my calculator. And I want to round my answer to the nearest foot. It's a good idea to always use the fraction button on your calculator when you're doing this. So I'm going to do alpha y equals 300 over sine of 41. Enter. So rounded to the nearest foot, that's 457 feet. So again, pause, try number two, come back and check. So here we know, okay, so here we have this scenario, which actually is all labeled for us. We're looking for how many miles he'll have to travel directly south. So that is this distance, which I'm labeling x. So here again is our angle, it's 27. So the 120 is our hypotenuse, and x is our opposite. So again, the ratio that uses opposite and hypotenuse is our SO, part of our SOHCAHTOA. So it's sine of 27 equals x over 120. So again, sine of 27 is just a number, so I cross multiply. Now, when you type this in your calculator, you need to be careful, and you want to always put the number first. So I'm going to do 120 times the sine of 27. I'm going to show you on my calculator, actually, that if I do sine of 27 times 120, oops, I didn't hit the times sign. It is a total, it gives me 0, versus if I say 120 times the sine of 27, I forgot to hit the sine button. I get 54.478. So if you insist on putting the 122nd, you need to make sure that you close those parentheses. then it will work. But my recommendation is always put the number in front. So our answer to the nearest mile, I forgot what it said, is 54 to the nearest mile. B, how many extra miles does the shipmate travel by going the wrong direction compared to going directly east? So here we need to find this value, which is directly east. So here we have two options. We can continue to use trigonometry, or that is a right triangle, so you could use the Pythagorean theorem. I'm going to use trig just because that's what we're learning, but the Pythagorean theorem would work as well. So here's my angle, so y is my adjacent side. So the one trig that uses the adjacent is ca, so it's cosine is adjacent over hypotenuse. So cosine of 27 equals y over 120. Again, I cross multiply, so I get y equals 120 cosine of 27. Do that on my calculator. And it's 106.9. I believe we're rounding to the nearest mile, so y equals 107. So he should have only traveled 107. He actually traveled 120 miles plus 54 miles. This is how far he actually traveled, which is 174. That's how far he should have traveled, so I do 174 minus 107. Which is 67 miles. So he traveled 67 miles too far. So again, try number 3. This one's a little bit trickier. Come back and check. The measurements of a triangle shown below are rounded to the nearest tenth. Calculate the missing side length to the nearest tenth. So I'm looking for this down here. Well, I don't have a right angle. So I need a right angle to use a triangle, trigonometry. But I can draw an altitude and split this into two parts, x and y. And I can use two different right triangles, this one to find x, the blue one to find x, and then the purple one to find y. So in the purple one, this is my angle. I know the side across from the right angle is the hypotenuse, and I'm looking for adjacent. So that is ca, which is cosine. So it's cosine of 42 equals a over 3.85. So that means 3.85 cosine of 42 equals a. Now it says to round to the nearest hundredth, but I should only round at the very end. So I'm actually going to leave a as that. Or not a, sorry. I called it y. I don't know why I switched a. Because I labeled it adjacent. So now I'm going to do the blue triangle. So again, here's my angle. I'm again looking for the adjacent side. And I know the hypotenuse. So again, it's cosine of 39 equals x over 4.04. X again is 4.04 times cosine of 39. And again, that's a decimal, and I want to round to the nearest hundredth, but I only do that at the end. So what I'm really going to do on my calculator is I want to add those together. So I'm going to do 4.04 cosine of 39 plus 3.85 cosine of 42. And I'm going to do that all on my calculator to get my final answer. There we go. I made it so I could see it. So I'm going to do 4.04 cosine of 39. I must close those parentheses plus 3.85 cosine of 42, and again close those parentheses. enter, and the answer is 6.000. So if I round that to the nearest hundredth, it's 6.00. And I don't remember my units. They didn't give me units. So that is my final answer. So again, pause and do number 4 and then number 1 and come back and check those two. Okay, so for this problem, what I did first of all is I kind of drew the situation. So I know that the diagonals of a rectangle are 22 and they intersect at an angle whose 110. And I'm looking for the length and the width of the triangle or of the rectangle. So I need to remember that when I'm talking about a rectangle, that the diagonals bisect each other. So that means that each part there is 11. I don't know that that's necessarily helpful, but I also need to remember that all my angles are right angles. And I'm looking for a right triangle I can use. But I need to utilize the fact that I know that angle there in the middle. So I know that the diagonals of a rectangle bisect each other, which means up top here, this is an isosceles triangle. So if that vertex angle is 110, that means each of these are 35 because it's x plus 110 equals 180. So each of those have to be 35. And then knowing that the opposite sides are parallel, or I can use the fact that this is a right angle, it really doesn't matter what right triangle I use. I can then use this right triangle, this purple one, to find the length and the width of my rectangle. Because looking at that purple triangle, this angle is 35. I don't need this one. And I know that this is 22. So I can put that diagonal back in there. I don't really need it, but it can be in there. Actually, let's erase it. So I'm looking at this right triangle now. It's 35 here. I'm looking for the length and the width, and the hypotenuse is 22. So in terms of 35, the width is adjacent, the length is opposite. So to find the width, I'm going to use cosine. So I'm going to say cosine of 35 equals W over 22. So 22 cosine of 35 equals W. And I just do that on my calculator, which is 18.02 more. We're rounding to the nearest integer, so it's 18. My length, I'm going to say sine of 35 equals L over 22. So again, I cross multiply and I get sine of 22 sine of 35 equals L. And just do that on my calculator. And is 12.61. So rounded to the nearest integer is 13. Last problem is, given these two triangles are similar, set up two ratios that are equal to the sine of A. So if I'm doing the sine of A, that would be BC over AC. And knowing the triangles are similar tells me that the sine of A and Q are congruent angles. So the sine of A is equal to BC over AC, but it's also equal to the sine of Q, because if A and Q are congruent, they're the same thing. So that's equal to RS over QS. So that's the end. If you have any questions, you can certainly ask me in class tomorrow.